Hi everyone, I'm Adrian, and I'm going to be talking about session save restore. This is what I've been working on for quite a long time. So I'd like to walk you through what it is, what progress has been made, what's left to do, so on. So let's start with what it is. What is this feature? So the idea is pretty simple, actually. You go into the settings app and you turn on that switch, and then at some point later, you're using your system, you have a couple apps open, you're doing something, and then for whatever reason, you need a reboot or log out or something. So your system goes away, the computer shuts down, everything should be gone. But then the next time you log in, your system's back to where it was, and you can quickly resume your work. All the apps are back, they're positioned the same. The content in the apps is back to where it was. So why do we want this feature? Well, it's a very commonly requested feature. Also at Red Hat, we have customers asking for this, but it was one of the kind of deficiencies that people like to point out about Wayland, that apps are not restoring their position on screen when you launch them, things like that. But also there are a few very practical benefits, like surviving crashes, not just of the app, but of the session, or even of the entire operating system. So if your kernel panics, generally you lose everything you were doing, but with session save restore, it is possible to actually then restore a snapshot taken, like, let's say, within the last 15 seconds, and then you can very quickly get back to what you were doing. For me, one of the more interesting benefits here is encouraging updates. So for robust updates, you really want to reboot your system because well, that's the more reliable way to do it. And if you have an immutable system, then you actually must reboot the system to apply that update. However, rebooting the system is quite disruptive. You lose everything you were working on, and for some people, like me, for example, I will have all my windows open and set up, and I'll work like that for a week or 2 weeks, but that means I'm not applying updates for a week or 2 weeks. So ideally, we should reduce the burden of installing updates so that people do that more. And the groundwork we lay here could be used for other fancier features. For instance, power management. Like mobile phones, what they will do is they will actually completely shut down your app to save either RAM or battery or whatever. And another thing is cross-device window handover. So like I think Apple calls this handover, where you have a window on one device and you can, if the app supports this, ask it to serialize its state, send it over to a different machine and restore there. And then, now I'm not saying that these are features we're actually going to be working on, but it sets the groundwork. It actually makes it possible even in theory. Did that just skip to the end? Okay. LibreOffice, what are you doing? Okay. So how does all this work? And we could start with some of the history, and that's the X11 Session Manager protocol. And it's quite simple. Apps register with the session manager, and in GNOME's case, this was GNOME Session. And the session manager keeps track of which apps were registered, and then on the next login, it just restarts all the apps. And the apps do all the saving and restoring themselves. And actually, they were quite forward-looking here. It's not using X11 as its IPC. It's actually using some bespoke IPC format. So theoretically, we could have used this with Wayland. But it has some problems. The kind of big one is that it's all command line driven. So when I said that an app registers with the session manager, I meant that the app gives the session manager a command to run at next login. And usually you would like serialize your state into a file and then put the file name and some command line flag and give that to the session manager to be restarted later. Of course, that means that none of this works with the sandbox. I mean, we don't want sandboxed apps to be able to tell the operating system to run some commands at login. It's also been broken in GNOME for quite a few years, and since we ported to systemd services to start up the actual GNOME session, it just hasn't worked. And so we dropped all of this code along with all the big GNOME session refactors and the X11 removal that happened a few releases ago. So if we want this to work with sandboxing, the replacement would be a portal, of course. And XSMP isn't really fundamentally that broken, so we're actually not diverging too far from it. Apps still register, the session manager still keeps track of what needs to be restarted on the next login. But instead of doing commands, we keep track of the app ID, and we relaunch it by relaunching the desktop file. So we just essentially just restart the app the way you would start an app in any other case. And then the app, on the next startup, it will re-register again because it is now running. And when it does that, the session manager will give it a, quote, restore reason. Now, the restore reason tells it what to do. So it'll tell the app, hey, this is just a normal launch. You should restore maybe your window position, but not the contents inside of the window. Or it can say you're doing a full session restore as much as you can. Or it could say that you're doing, you just crashed. So maybe restore some things, but be careful to not get yourself into a crash loop. And I'm glossing over lots of complexity. There's like tracking for multi-instance apps and all that that's relevant for other desktops, but isn't really a thing in GNOME. Wayland. So X11 with XSMP, the app would save everything itself, including all the window management state, because on X11 an app could do that. So it would just save its position, and it would ask the X server for its position and size and all the window management flags it felt like asking about, and then it would write them down and then later restore them. Okay, there we go. But on Wayland, apps can't position themselves for lots of reasons. So instead, with Wayland, we have this XDG session management v1 protocol where the app doesn't do any of the window management saving. It asks the compositor, hey, can you save my state and give me a token, just a big random number essentially. And then the compositor saves everything, and then later the app gives that big random number back to the compositor, and the compositor will say, will restore whatever makes sense to restore in this context. And this is better than what we had with X11, I'd say. First, it's more consistent because there's one centralized place that decides what gets saved and what gets restored. But also, the compositor can execute some kind of policy that makes sense for the desktop. For instance, like we give the restore reason to the compositor here as well. So on a normal app launch, the app might restore its position, but we don't want to restore the workspace that the app was on previously because we're just launching the app normally. And it would be really weird if you were on the third workspace and you launched the app and it opens on the first workspace because that's where it was last time. With the old X11 way of doing things, the app would have to think of that edge case and would have to be aware of workspaces, which it might not have been, and different desktops do things differently, and then, this becomes this whole mess. With the Wayland protocol, the compositor decides that during normal launches on this desktop environment, it doesn't make sense to restore workspaces, so it doesn't do that. Now let's get into the hardest part of all this, and that would be GTK. Because one thing that we were really missing with XSMP is this nice high-level API for apps to interact with session save restore. And so it wasn't that popularly implemented by apps. And I believe that if we want apps to support this, we need to give them an easy way of hooking into the system, or at least as easy as we can make it. So the overall approach with what I want to put into GTK is, well, first, GTK application drives it all. It talks to the portal, it handles the Wayland protocol, and so on. So it's kind of built in that way. And it would be built around what I've been calling state snapshots. So the idea is that the app is running, it's in some state at any given moment in time, and then at that moment in time, GTK can decide, hey, I want to collect all the state, like snapshot the app as it is right now, serialize that, write it to disk somewhere to be later restored. We handle this per window, so GTK is natively aware of the different windows, and it actually, like we could have done this in such a way where we just, in the GTK application, we have some signal to collect and restore, and then the app would have to loop over all of its own windows and do that. But we made GTK application aware of this because it actually fixes quite a few edge cases that I'll get into. Restoration before activation is quite important. So restoring an app has quite a few life cycle implications. Like, for instance, if you have an app that was previously saved and then it's not running at the moment for whatever reason, and then you open Nautilus and double-click a file to launch that app, what does the app do? Does it restore first? Does it open a new window to handle that file? It's not really clear. However, there is a case where we already handle this, and that is if an app was already running and the user was already doing something in it, maybe they have a couple windows open already, and they launch the app, and the app needs to decide what to do with that activation request anyway. So my thinking here is that restoration isn't really that different from an app that's been running for a while and the user's already done some things in there. So what GTK will do is when you launch the app, it will restore the app first. And that will bring the app up to the state where conceptually it's the same state as if the user has been using the app for a while, has a couple windows open, and so on. And then we give the app the activation request. And that means that all the edge cases of save restore lifecycle kind of go away because we pretend that that case is the same as the case of an app already running. We have a periodic autosave feature, and the reason for this is that crash resilience I mentioned earlier. We want the apps to be able to, like when they're active and focused, I think it's every 15 seconds is what the code does, but it's customizable per app. GTK will serialize the app state. It'll take a snapshot and save it so that if the app crashes or the session crashes or the kernel crashes, you lose at most 15 seconds of what you were doing in your last focused app. And the overarching goal here is that GTK hides all the complexity. And that's including the Wayland protocol, and that's including a bunch of these edge cases. And I'd like to walk through one of these edge cases just to kind of demonstrate why this is so difficult. So here's an example edge case. The user is running an app. It's a multi-window app. So when they close like the second or third or fourth window, we don't actually want to ever restore those again. Because during a normal launch, we only launch the one window, and the app is that window when you close it, and the app keeps running, and the user is done with those windows. There's nothing to restore there. But then they close the last window of the app, and this one we do actually want to save because on the next launch of the app, we want to restore some things from there, like the size and position on screen. So GTK dutifully collects the state of this window to save. And then let's say that for whatever reason the app doesn't immediately exit. Like the last window is gone, but maybe the app is being held running by a search provider or it's running some task in the background, whatever. The app keeps running. And then the user changes their mind before the app quits. They open their app grid and they relaunch the app. The app never quit, so it gets reactivated. But this is, from the user's perspective, like we relaunched the app, they're being shown the first window again. So actually, GTK needs to restore that window, but it needs to not restore the rest of the app. It needs to run part of its restoration machinery because the app was already running. So parts of the app that remained instantiated shouldn't be restored because they're still alive. But this new window should be restored. So this is an example of one of those edge cases where GTK needs to be aware of windows and needs to be very careful about when it collects state and so on. And actually, from a code perspective, this is even more complicated because GTK isn't writing this last window to disk necessarily. It actually needs to serialize it and keep it in memory to use it later. So yeah, there's lots of edge cases like this to handle. So given that overview, we have the first API that made it into GTK. And this one was quite simple. We have signals to collect state into a G-variant dictionary, and that is our method of serializing the state. And then we have signals to restore the state from the variant into the app. And these signals were on GTK application and GTK application window. So those two classes were special. They got special treatment by GTK application. They're a special case. And this entire API is completely synchronous. So we just emit the signal. And when all the signal handlers return, we assume we're done. We assume all the state has been collected. That's it. And this API got actually pretty close to landing in GNOME 50, or that's GTK 4.22. We almost released this. It also has a GNOME Builder integration, which these restore reasons I mentioned earlier, the portal will give you the correct restore reason. But if you're testing your app, you actually want to be able to spoof those to check that your app behaves correctly under all those different circumstances. So in GNOME Builder, and this is already there today, though it doesn't do much because this all hasn't landed yet. Next to the run button, you can drop down in there, and there's an option to emulate a restore reason. The first API had a couple of drawbacks. So first, it was entirely code-driven. So if you're an app developer and you want to collect some state from a bunch of G objects, and your state is in properties, for instance, you're going to be writing quite a bit of code that's like G-object get the property out of the object, and then you store it into the variant, and it's just a lot of repetitive kind of code. The other issue is that because these signals only exist on like kind of the top level of the app's hierarchy, and that's the window and the application itself, the state there is kind of flat. So you're given one variant to serialize into at the top level of your app, and that's it. But apps aren't actually flat like this. They have navigational hierarchies. Like the settings app has a bunch of subpages in them, and each subpage may want to save and restore different state than any other subpage. But this API wasn't particularly well suited for that kind of nesting. There was no helper for building up a tree of state that you would want to then kind of pass down your navigation hierarchy. Because we had special classes, there was no extensibility, so there was no kind of defined way to take some random data type that you have that you may want to save and restore and mark it as this can be saved and restored, give it into the system, and then let the system take care of it. There was none of that, so you would have to, this was just missing. It also lacked bulk data support. So what's bulk data? For some apps, like I'll give an example of GNOME Text Editor, you may have like all the window state you want to restore, but then you also have this unfinished text document in there that may be many megabytes in size. And we don't actually want to serialize that text document into this save restore system, because then we're copying the data into memory, and we're then writing it all to disk, and it's so much unnecessary work, basically. And the file might be quite large. We don't want to do it like this. So instead, what we want to do is we want to save that to a file somewhere off to the side, and then save the file name in the G variant, so that we don't have to have any special code paths about copying the content into the save restore state. And ideally, this keeps the save restore, the state snapshot small, so that this whole system's kind of quick, and it's not going to bog the system down too much. And on other platforms, they also have this restriction, and some actually go further. Like Android has a hard cap of, I think, 1 megabyte. Like if your state ends up being more than 1 megabyte, it just will not accept it. And then the biggest drawback is that apps want to do asynchronous things. And for example, back to this GNOME text editor example, when you save the text document to disk, that's an asynchronous operation. It may be a very large file, the disk may be slow. We don't want to hang the app while we serialize everything. So we want this to be async. However, the API is fully sync, so you can't do that. And this async problem is kind of what ended up killing the first API. So I was thinking originally that there was some way to kind of retrofit async into this API and just let it be. But it comes with a big pile of race conditions that we couldn't fix. With if that API had landed, we would be stuck with a bunch of race conditions that would make it not feasible. Like the obvious example would be that if an app is being shut down because the session is ending, the app will try to serialize its state, and that's asynchronous. And before it's done, GTK is not keeping track of the fact that the app is still doing something, and so GTK exits because it thinks there's nothing left to do. Meanwhile, the app hasn't finished saving its state, so then the next time you launch the app, the state's gone. Whoops. But there's another edge case, and so GTK application is a subclass of G application. And that means that when you're an app developer and you're connecting to like activate and open and command line, all those activation signals that tell you that a new instance of your app has been launched, those are the raw signals from glib. And there's no way to delay that signal emission. And so what this does is it breaks this edge case from before. And let's go back there. So this edge case, again, user closes the last window of the app, GTK saves the state, app doesn't exit, user relaunches the app. So what happens if GTK collects all the state to save is now asynchronous? Now we're doing a bunch of work. And rather than the user relaunching the app before the app exits, the user changes their mind and relaunches the app before the app is even done collecting its state. How do you fix that? I couldn't think of a way. I don't think it's fixable. So the decision was made that there's actually no way to retrofit async support into this API. And this issue came up because I actually published this API to app developers, and a few apps actually got ported. And one of the big pieces of feedback was, well, I want to do something async here, but I can't. And they would come asking me, well, how should I do this? And I'm like, well, you actually can't do that. So right in time for 4.22, I think like right before the RC or something, we pulled this API. We just hid it, basically. All the public API pieces got deleted, and all the plumbing is still inside of GTK, but it got hidden. And then immediately after the release, we reverted that and brought it back, because I was hoping that for GNOME 51, we would have a second API. So I wanted to kind of minimize the amount of change to the first API. So I thought, well, let's just invent async GObject signals. And it didn't end up being quite as hard as you'd imagine. The idea is it's just a signal where you give it this async signal context thingy. And if you want the signal emission to become async, you call defer. And for every call to defer, you call complete later. And it would also have some plumbing for returning values from your async signal handler. So you would call return. And this would be like gtask. So there would be return bool, return pointer, return error, and so on. And then the emit function for that signal would be asynchronous. And then all those return values would go through an accumulator. It's a glib signal, but asynchronous. And if you don't need asynchronous work, then you would just simply never defer that context, and now you have just a normal synchronous signal. And then we also went through and fixed a lot of the other limitations of the first API. So now there's an interface, GTK restorable, which you could implement in any object, which would give you these async signals and then would let you participate in the save restore system. And this would come with default implementations for common widgets. So like, for example, libadwaita's navigation view would delegate these down to all of the subpages inside of there. And then all widgets would actually implement this as a no-op, so that anywhere in your widget tree you can collect some state and then construct a state tree. And when I say state tree, yeah, so it was a flat bit of state, but now it is actually a tree. So we fixed that limitation. We added bindings. So the idea is that you can take a GTK restorable and bind it into another one under some name, or you could bind a GObject property into some name inside of a GTK restorable. And so the idea is that that's a more declarable way to collect your state. And then we integrate it with GTK Builder so that you could do this completely declaratively in your just UI definition file. And it came with the solution for bulk data as well. But the second API was overwhelmingly rejected by the maintainers of GTK, by the libadwaita maintainers. And the bit of feedback I got was that async signals is not something people are interested in, which, fair enough. So now, the last couple of weeks, I've been working on a third API proposal, which is not too different from the second API proposal. Like, we keep most of those benefits of the state tree and bindings and all that. But we came up with a slightly different way of doing it. So there's no more async signals. GTK restorable now has async methods or vfuncs. And now, since it's just an interface and there's no weird machinery for, like the bindings in the second API relied on connecting to the signals. Since there's no more signals, we can't do bindings this way anymore. So instead, now we have this GTK state node object. It's a class, which is itself is a restorable, but now it has bindings. So the idea is you have a tree of these state nodes or simple restorables, and you can kind of plug it together and assemble your state tree that way instead. And the big feature here to make this nicely usable is delegation. So you can implement a GTK restorable on your class, but internally you can have a GTK state node. And if you want to implement GTK restorable for yourself, you could just delegate the implementation to the GTK state node. So this way, we kind of get the benefits of the second API without using async signals. Now, yeah. So when's all this landing? So the Wayland bits are mostly there. The protocol's been released. It's a staging protocol, which means it's ready for use by toolkits and compositors and all that. The Mutter side of this landed in 51.beta. However, I know that there are some bugs to iron out when you actually put this together in a full session save restore. There's some jank. And the GTK parts, the Wayland parts for GTK were released in GNOME 51 alpha, but it's not usable by apps yet. Then the portal, so the front end, which in portals this is backwards, the front end is the API that apps talk to. So the portal front end is, it's not quite done yet. The KDE people have, I've talked to them, they've okayed the kind of core concepts of the portal. Same with some Firefox developers that I talked to. It's one of their more complicated apps that I wanted to make sure that it's suitable for them. But the details still need work, like the specific restore reasons and some of the language in there. So that's a pull request that you can look at to keep track of this work. Now the GNOME backend, there's a private API inside a GNOME session that landed in GNOME 50. And then I have a conversion of that API into an actual proper portal backend that's waiting in a merge request, that's waiting for the front end bits to land. And the KDE people, I know they're also working on a backend, but they would also be waiting for me to land the front end work. So they're waiting for me to get this part done. And then the GTK parts. So the third API's basics are in a branch. And right before GUADEC, I pinged all the GTK maintainers and basically asked them for some feedback, which I'm sure I will be getting at some point within the next few weeks. So it's not, I'm not sure what the reaction is yet, basically. But also the first API is still in GTK, and it's still exposed. I haven't plumbed all these basics into the actual, into G application and all of its handling of the portal and of Wayland and so on. So the first API, which is still exposed, will probably be hidden again in time for GNOME 51 so that we don't release it and don't accidentally stabilize it. And ultimately for the GTK bits, I would really like to have some apps ported to this before we make it stable in GTK, because it's such a big and complicated API that we really need to be aware of what the ergonomics look like before using it, before stabilizing it. So ultimately, we're not making it in time for GNOME 51 for session save restore, unfortunately. But that's kind of the status. So if you have feedback over this API, if you're an app developer and have ideas, please message me on Matrix or talk to me in the hallway. So thank you all for your time and your listening, and happy to take questions.
In the past 7 years, I developed and maintained a shell extension with the future exactly same as what you presented today, and over the years, over the years, I also saw some extensions with the similar feature, but in a different way, in the official extension website. So after this feature roll out in the future GNOME version, what does it mean to those extension? And will you provide some APIs for extension, and will you provide a switch so that in the extension this feature can be shut down, and then extension take over this feature?
I'm sorry, that wasn't the easiest to hear. Are you saying that one of the questions was if there's an option to turn this off? Yes, there is. There's a user-facing option in the settings app, and there's a API-facing option if your app doesn't, like your app has to opt into supporting this. But I'm sorry, I didn't really get the rest of your question. Could you repeat that, please? Yeah, it was a little quiet, sorry.
My first question is because there are some extensions to do this stuff, to do this feature, like mine extension already do save and restore sessions. So if after this feature officially roll out in the future GNOME desktop, what does this mean to those extensions?
Oh, about shell extensions. Oh, so what does this mean for shell extensions?
Yes, shell extensions, sorry, GNOME shell
yeah, okay.
extensions.
I suppose that shell extensions could probably, I mean, I might not be the most informed about shell extensions. My impression is that many of them are kind of stateless, like a lot of them are either do some cosmetic change to the shell, which they don't really have any state to save or restore there. A lot of them are status indicators of some kind, either in the quick settings panel or something like that, or they'll show your tail scale connection status or something. And those you can just query the underlying service or the underlying setting. As for if there are stateful shell extensions, I don't see why they wouldn't be able to, well, they wouldn't be able to talk to the portal. But they are inside of GNOME Shell, and GNOME Shell is involved in save restore through Wayland. So GNOME Shell is kind of always saving and restoring its state in a way. Like it doesn't talk to the portal, it just always assumes that it needs to save and restore state because it's driven by the Wayland clients asking to restore Windows state as needed. Yeah, I don't know. I would have to think about, if you could give me examples of, message me on Matrix or something, of examples of stateful shell extensions, I'll give it a think.
Maybe I will send mine shell extension links to the, in the Matrix room. You mean?
Sorry? Yeah.
Okay. As a second question is, will you provide shell API for the extension for, yes. So
Okay, yeah. So shell API, I would have to see what, I would have to think about it. I would have to see what shell extensions need, and then from there we can see. Because it does complicate things. The shell cannot talk to the portal.
yeah, I think it will be useful because in shell extension we can do anything to modify anything to add any useful, intuitive, fancy features. I think that would be useful.
Mm-hmm.
Okay. Thank you.
Thank you.
Any other questions? So we can take one more question, otherwise, actually, we are running out of time.
Since models are defined on the GIO layer, and some people might have some state stored on there, not basically in GTK, wouldn't it perhaps make more sense to, instead of have a GTK state node, a G state node in a lower layer?
It could, I suppose. But the problem is GTK application needs to run all of this because there's involvement with Wayland, there's involvement with talking to a portal, which like GTK will do, but like glib isn't doing. Well, it does talk to portals sometimes, but it's not like GTK application will register with the portals. It'll give the portals an app ID, which with that kind of thing we do need for this to work for unsandboxed apps, for instance. So, and it also needs to be aware of GTK windows, because otherwise we get all these edge cases that you would have to handle yourself in the app, which is, I don't think that's a feasible solution there. So because all the logic to drive this is in GTK, then does it make sense to put parts of it in glib? I suppose it might. Maybe you do want to serialize something, just anything that could be could use glib. That might make sense. But also glib doesn't really want to accept new APIs unless they've been tested somewhere else first. So maybe we keep it as is in GTK for GTK4. And then in GTK5, maybe we decide that this API is good and works, and then we can upstream it into glib and then to do something like that. I don't know.
So one last comment, because we are running actually over time. A person in the chat, thank you so much to people who are actually interacting remotely. He's saying about the question that the gentleman did before. Their question is actually, they have written a shell extension that already implements session save restore in some way. What does this new development mean for their extension? I'm going to ask you to be very brief if you have an answer for this. Not about saving state of extensions.
Okay. I see. I imagine that if there's an extension that implements this feature and then apps just natively support this now, then that extension probably isn't necessary. But there will be a transition period where apps do need to opt into the system. So for apps that don't opt in, the extension might need to keep working for those apps, maybe, like if you want to do it that way.
Thank you very much. Thank you.